So we're going to work through these notes, and we're going to begin by talking about complementary relationships. So this is what we went through in the little presentation that I went through just before. So I'm just going to give a quick review again of it, and we're going to write in some notes here. The first thing I've done is I've put in this writing here, so you might want to put that in. As you can see, what it's telling me is, for instance, the cos of theta here is just the x value, so it is a. And you can see the length of it there, it's just this length here, a. So the cos of theta is a. If I now take the sine of its complement, remembering that a complement means it just adds up to 90 degrees, so this would be pi on 2 minus theta, because this angle plus this angle would be equal to 90 degrees. So the sine of the complement of theta is going to be the y value, isn't it? So it's going to be a. So do you see how the cos of theta is equal to the sine of its complement, because the cos of theta was a, and the sine of its complement is a as well. So we can come over here now and we can write in a definition. So sine of pi on 2 minus theta is going to be equal to the cos of theta. And we can also say the same thing for cos of pi on 2 minus theta. It will be the sine of theta. So the way I like to remember it is whenever I've got pi on 2 or one of its multiples, I'm actually going to swap the sine to a cos or the cos to a sine. So as soon as I see pi on 2 plus or minus theta, I know what I'm going to do is I'm going to take that sine and change it to a cos, or take that cos and change it to a sine. Okay, let's move on to our next one here, and we're going to have to write down some definitions for the second quadrant. Well, as you can see here, I'm going pi on 2 minus theta. So let's think about where pi on 2 is. Pi on 2 is up here, right? So I've got pi on 2, and now, if I quickly grab another color, I'm adding theta to it. So I'm up here. That there is theta. So now I'm here. We won't put in all the writing again. It will just take a bit too much time, but we can just look at this and we can say a few things. We can say now, well, the sine of pi on 2 minus theta, I'm now over here. I'm going to swap the sine to a cos. So to over here, I'm going to take this cos and I'm going to change it to a sine. But here you have to be careful, because the cos in my second one is going to be negative, isn't it? Because cos over here is my x value, so now they're going to be negative. So I have to put a negative in front of my sine. It's going to be negative sine on theta. If we wanted to, we could put in all our markings here to prove this to ourselves. So for instance here, this is my b, but do you see how it's now negative b? And my a is still positive. So my a is still positive, but now my b is the negative one. So that's why this is now negative sine there. And then we can keep on going here. So let's look at our third quadrant. So this is when we're going 3 pi on 2 minus an angle. So let's think about where 3 pi on 2 is. It's down here, isn't it? So I'm going 3 pi on 2. And I'm minusing theta here. So now I'm down here. This is theta again. So 3 pi on 2 minusing that theta. So I'm here. So what can we say about this? Well, sine is going to turn to a cos. And sine is negative here, isn't it? So it's going to be negative cos of theta. So too over here will be negative sine of theta. If you wanted to, you could draw in all your markings here. It might get a bit time consuming, so you might not want to, but you can see here that this is negative a, and this is negative b. And then we would keep on going to our fourth quadrant here, and this is where it might just get a bit too messy, so I might not do in the markings here. But hopefully you can see that my sine here is negative, so it's going to be negative cos of theta, and my cos here will be positive, so it will be sine of theta. And those are all the key definitions that you need to know. As always, don't just brute memorize this. What you should be doing is thinking about it. So you're thinking about, oh, I've got 3 pi on 2 plus theta, so I'm obviously over here. And I know that in my fourth quadrant, my sine is negative, so it's going to be negative cos of theta. So thinking it through is the important thing here, and not just doing it by brute memory, because you're not really understanding it if you're doing it that way. So I want you to understand what you're doing. Okay, we'll leave it here and we'll go through some more examples real soon.